The Space Shuttle Challenger disaster provided an unlikely, yet profound, lesson in engineering and human error. Engineers learned a critical, irreversible lesson about overlooked flaws and the true cost of imperfection. Every groundbreaking invention, from the light bulb to life-saving medicines, began with countless, frustrating missteps. These seemingly catastrophic failures became essential stepping stones, forging paths to unparalleled innovation and success. This relentless process, known as trial and error, forms the very bedrock of scientific discovery and human ingenuity. It champions the courage to experiment, the resilience to fail, and the wisdom to learn from every setback. Consider the sheer complexity of sealing a high-pressure system, like the rocket boosters of a spacecraft. A simple O-ring, designed to expand and plug a critical gap, represents a perfect fit for this challenging task. However, designing the ideal seal, one that withstands extreme conditions, demands meticulous, iterative refinement and testing. Early engineers faced similar challenges, requiring countless attempts to create effective, reliable mechanical connections. They needed to discover the precise material composition, the optimal shape, and the perfect dimensions for ultimate integrity. Each failed attempt provided invaluable data, revealing crucial limitations and pointing towards necessary design modifications. This iterative cycle of design, test, analyze, and redesign ultimately drives all true technological advancement forward. Without embracing this persistent struggle, many indispensable inventions would simply never have come into existence. Understanding this process reshapes our perception of failure, transforming it into an indispensable tool for progress. Imagine ancient artisans crafting pottery, continuously adjusting clay consistency and firing temperatures through observation. Their trial-and-error approach slowly perfected durable, watertight vessels, essential for storing food and precious liquids. Similarly, early inventors of electrical connectors faced myriad challenges in standardizing reliable power delivery methods. Different voltages, varying current demands, and diverse device designs necessitated an array of unique plug configurations. Early iterations often resulted in sparking, overheating, or simply failing to establish a secure, consistent electrical circuit. Each flawed prototype offered crucial insights into material conductivity, insulation requirements, and terminal design geometry. Engineers meticulously documented every failure, categorizing causes like poor contact pressure or inadequate safety features. But that's not the only challenge. Thermal expansion and contraction also posed significant, often overlooked, engineering dilemmas. They experimented with different metals, alloys, and insulating polymers to withstand repeated stress and environmental fluctuations. Consider the subtle art of ensuring a plug remains firmly seated, preventing accidental disconnection under everyday usage. This required specific latching mechanisms, or frictional fits, each refined through repeated testing and user feedback loops. Countless designs were discarded, deemed unsafe, impractical, or simply incompatible with existing infrastructure and standards. The sheer variety of electrical outlets across the globe serves as a tangible monument to this complex evolutionary process. Wait until you hear about the crucial role of international standardization committees in navigating this chaotic landscape. These bodies painstakingly evaluated myriad plug designs, seeking universal safety and interoperability across vast regions. Their work involved extensive testing, identifying potential hazards like electrocution risks or fire ignition possibilities. Every successful standard emerged from a graveyard of failed proposals, each contributing to a safer, more connected world. The seemingly simple act of plugging in an appliance represents centuries of collective, incremental refinement and learning. It's like a complex puzzle where every wrong piece reveals crucial information about the correct, ultimate solution. Inventors like Thomas Edison famously embraced this philosophy, viewing every failed experiment not as a loss, but as progress. He famously remarked about his light bulb journey, "I have not failed. I've just found 10,000 ways that won't work." This mindset transforms obstacles into opportunities, leveraging errors to pinpoint the exact path towards a viable outcome. And then something unexpected happened. Sometimes failures led to entirely different, unforeseen breakthroughs. For instance, mistakes in one experiment might reveal properties useful for an unrelated application, sparking new innovations. The accidental discovery of penicillin from a contaminated Petri dish exemplifies this serendipitous consequence of unexpected error. It underscores how embracing the unpredictable nature of trial and error can unlock entirely novel avenues of exploration. This profound understanding of iterative refinement empowers innovators to approach challenges with greater resilience and optimism. It teaches us that perfection is not a starting point, but rather a distant horizon reached through persistent, informed iteration. Embracing mistakes fundamentally shifts our perspective, transforming perceived failures into valuable, actionable intelligence. Companies applying this philosophy consistently outpace competitors, rapidly adapting products and services to evolving market needs. Scientists, engineers, and artists all leverage this principle, pushing boundaries and achieving seemingly impossible feats regularly. It fosters a culture of psychological safety, where individuals feel empowered to experiment without fear of punitive repercussions. This environment encourages bolder ideas, accelerates learning cycles, and ultimately leads to more robust, innovative outcomes. The ability to quickly identify, analyze, and correct errors becomes a superpower in a world demanding constant adaptation. It's the difference between blindly repeating mistakes and systematically eliminating them, one informed adjustment at a time. Personal growth mirrors this process, where missteps in career or relationships offer profound, transformative learning experiences. By reflecting on our personal plugs that didn't quite fit, we discover better strategies for future endeavors. This continuous feedback loop cultivates deep understanding, preventing the repetition of past errors and fostering true mastery. Ultimately, the willingness to be wrong, to fail publicly, and to learn transparently defines true progress for humanity. It's a testament to human spirit, transforming apparent setbacks into catalysts for monumental advancements across every field. Learning from mistakes and embracing trial and error is not merely a method. It is a fundamental philosophy of advancement. Every imperfect attempt, every plug that didn't quite fit, contributes vital information for discovering the perfect solution. So, next time you encounter a setback, remember it's an opportunity to learn, adjust, and move closer to breakthrough success. If you found this exploration of iterative discovery fascinating, subscribe for more incredible stories like this one. Hit the like button and share your own experiences with learning from mistakes in the comments below. We'd love to hear them.